In this class, we are going to discuss a next topic, signed binary numbers. So, what is meant by a signed number means the difference between a normal number and a signed number is it is having some sign. Okay, so what is the difference between normal number and signed number means this signed number having some sign that is represented as positive or negative. Okay, so if you are going to represent a normal number, for example I am taking one number here, so that is 6. Okay, so if you are representing if you are going to representing normal number 6, that is different. And if you are going to represent plus 6 or minus 6, that is somewhat different, right? So if you are going to represent a normal number 6, this is somewhat different. And if you are going to represent a positive 6 or negative 6 number, may be different, right? So up to now we know that according to previous class, we know that how to represent a normal number and how to represent a normal number into binary number, right? Already we know, right, how to represent a normal number 6, and this number can be converted into the binary. We know how to represent that. So for example, this is a normal number to represent 6, right? So this number may be represented in binary, means that may be represent as 3-digit code, or maybe it requires 4-digit code to represent in binary. So that 3-digit code for 6 is nothing but we can represent it as 8421 code, that is 110 binary code, right? So if you want to represent 4-digit code, that is nothing but we can represent like this, that is 0110, right? Already we knows how to represent a normal number 6, and how to represent that normal number into binary representation is nothing but it requires 3-digit code or maybe 4-digit code, right? So that means we knows how to represent a normal number and we knows how to represent a binary number, right? So and here also we need to represent that positive number and negative number. So this positive and negative number, how to represent it in binary, that we need to know. Okay, so compulsory we have to implement how to represent a positive number and how to represent a minus negative number, right? So that how to represent means, so according to this, take out this confusion, like how to represent a positive number and how to represent a negative number in binary equivalent means we are having the topic, that is representation of signed binary numbers. Okay, so to implement a positive number and a negative number in binary equivalent by using signed binary representation. Okay, so how to represent means these signed binary numbers are classified into two types. The first one is signed magnitude form. Okay, and the second one is complement form. Okay, so to represent a positive number and to represent a negative number in binary. Okay, so in binary, to represent a positive number and to represent a negative number, how to represent positive and negative means we need to represent this plus sign into binary and this minus can derived into binary. Okay, so how to represent a positive and negative number means by using these two forms we can implement that positive and negative numbers. Okay, so and here what are the types we are having in signed binary numbers? The first one is signed magnitude form and the second one is complement form. Okay, so in complement form again we are having two forms. Okay, so again we are having this complement form will be classified into two types. The first one we can derive as ones complement, already knows these methods, and another method is two's complement form. Okay, so in class complement form again we are having two forms, those are ones complement and two's complement. Okay, so in that first we will discuss sign magnitude form. Okay, so and later we will discuss complement form. Okay, so first we will discuss sign magnitude form. So in any form, whatever the number we can implement it in signed magnitude form, or maybe next we are going to discuss in complement form. So this positive sign and negative sign we can call it as the signed bits. Remember the point. We can represent whatever the number in sign magnitude form, or later we will discuss in complement form. So in that, any number can represented in two forms. The positive and negative can be represented as, we can call it as the sign bits. Remember the point. Okay, so whatever the number that may be plus 6 or minus 6 plus 7 or minus 7, like that you need to implement the positive number or negative number. So in that we are calling the plus and minus, we can call it as the sign bits in whatever the form. Okay, so in these two forms, the positive we can represented in binary as 1. Okay, sorry, in binary form the positive can be represented as 0. Okay, so this plus is considered as 0 in binary and minus is considered as 1 in binary. Okay, these two we can call it as the sign bits. Remember the point. Whatever that form we can implemented in any number. Okay, so in any form, that may be either sign magnitude form, or maybe next we are going to discuss in complemented form. So this plus is considered as 0 and this minus is considered as 1. Okay, that means these two we can call it as the sign bits. Okay, so that sign bit representation for plus is 0 and minus is 1. Okay, so now we will go for syntax of first sign magnitude form. Okay, so now we'll write the syntax of sign magnitude form. That means how to represent a positive number and how to represent a negative number of binary in sign magnitude form means by using this syntax. Okay, so how to represent the sign magnitude form of positive and negative form means that is, this signed magnitude form of syntax we can represent it as sign bit with actual number, actual binary number. So what is the syntax of signed magnitude form means? So this is the syntax of sign magnitude form is sign bit with actual binary. So this is the syntax of sign magnitude form. So for example, if you want to represent a 6, okay, so if you want to represent a 6, the actual binary number is, for 3-digit code we can represent it as 110. Already we know, right? For suppose if you want to represent a plus 6, if you want to represent plus 6 in signed magnitude form, okay, so if you want to represent plus 6 in signed magnitude form, what is the process means? So we are going to represent it in syntax. Okay, so the sign bit represented as, how to represent plus 6 means, so that plus 6 we can represent it as like this. Sign bit is nothing but, already I explained here, plus and minus we can call it as the sign bits. That's why in the sign bit I can place it plus, and the actual binary is nothing but what is the binary will what is the number will have, that is present here first. Okay, now this number will be converted to the this formation. So sign bit is plus, we can consider as in binary is nothing but, now this form will be converted into the binary actually. Okay, so how to convert that binary means, already we know plus and minus we can represent it in binary as 0 and 1. Like that, plus is represented as 0 in binary, and 6 already we know what is the binary number of 6 is nothing but, that is 110. Okay, so finally plus 6 of signed magnitude form we can call it as the 0110. Remember the point. Okay, if you want to represent it in 4-digit code, how to represent it means, so for plus we need to represent 4-digit code, that is nothing but 4 zeros we can placed here, and for 6 4-digit code is nothing but, what is the number here, 0110. So for plus 6 4-digit code we can represent it as like this, 4 zeros and 0110. In 3-digit code we can represent like this. So here we can represent only in place of plus we can represent only 3 zeros or 0, no problem. Okay na? So 10 if you want to place in the place of 6, if you want to represent 3 digit, no problem, 3 digit of zeros placed in the place of place, no problem, you can represent like this also, 000 110. This is the plus 6 of signed magnitude representation. For suppose if you want to represent minus 6 in signed magnitude form, what is the binary number of minus 6 means? Already we know by using of syntax we need to implement minus 6, right? So this is the sign bit, we can call it as the minus. Okay, and actual binary is nothing but whatever the number will have, that will be converted into the actual binary. So minus, how to represent in binary? That is nothing but 1. And 6, what is the binary form? That is 110. Okay, so that means minus 6 of binary number, we can call it as the add the all numbers. So 111 for 4 digit code you need to write that. So in the place of 1 we need to implement 4 digit of binary number of minus is 1111. 4 digit of 6 is nothing but 0110. So finally we'll get the result of minus 6 in signed magnitude form is 11110110. This is the 4 digit code. Okay, so like this we can implement signed magnitude form. Okay, so and here in that syllabus will have only signed magnitude representation, no need to implement complement form. So in the place of complement form we'll have the arithmetic addition and arithmetic subtraction. Okay, remember the point. So the complement form will discussed in later. So but in the syllabus will have the arithmetic addition and arithmetic subtraction will have in that. Okay, so this is the signed magnitude form. Now we will discuss about arithmetic addition and arithmetic subtraction. So the addition and subtraction, what is the normal process, how to add any two numbers and how to subtract any two numbers, we know, right? So like that, here the addition of two numbers in arithmetic addition, the addition of two numbers in the signed magnitude system follows the rules of ordinary arithmetic addition. Okay, so how to do the arithmetic addition means this addition will follows the how to do the normal addition process, what are the rules will have in that normal addition process, the same rules will be obey the same rules will be follows the arithmetic addition here. Okay, if the signs are same, that means for example I can take here two numbers, that may be 12 and 24. These are the two numbers we need to add. So these two numbers having the same sign, that may be positive. So for that two numbers we need to add for two magnitudes and give the sum to the common sign. So that means if the signs are same for the two numbers, we need add two magnitudes, right? We need to add two magnitudes is nothing but we'll get the result as 36. For that result, what is the sign we will give? So that is nothing but whatever the numbers will have the same sign, that sign will be represented to the result of that addition, right? So if the signs are different like this, okay, so 24 having the plus sign and 12 having the minus sign, like this, if the signs are different, we subtract the smaller magnitude. Okay, we subtract the smaller magnitude from the larger and give the result. Okay, so whatever the result will get here, the sign of the larger magnitude. So whatever the result will get, that result will having the whatever the larger magnitude having sign, that will be present here. Okay, so if the signs are having if the two numbers having the same sign, the result will be follows the same sign. Okay, so if the signs are different for the two numbers, whatever the larger number having the sign, that sign will be follows the result. Okay, so the same procedure applies to the binary numbers also. Here we need to add the arithmetic addition, that is binary numbers we need to add here. So the same procedure applies to binary numbers in signed magnitude form. Okay, so now we will do that by using some example. Okay, so the addition of two signed binary numbers with negative numbers represented in signed complemented form. So here just represent what is the positive number we'll have here, 24, right? So what is the negative number we'll have here, 12. So first we need to convert this number, this is the decimal numbers, no? So in arithmetic addition we need to add binary numbers, first one, right? I need to clear steps. The first one is in arithmetic addition. So whatever the numbers will have in decimal, Okay, if you are giving the numbers in decimal, that decimal will be converted into the first binary. Okay, the first step is whatever the decimal number will have, that will be converted into the binary with sign bit, including their sign bits. Okay, including sign bits, we need to convert binary formation. For example, plus 12 will have here decimal number. So this plus will be converted into the binary formation, as well as 12 will be converted into the binary formation like this. So plus, how to convert in binary? Zeros. And 12 will be converted into like this by using 8421 code, right? So that is the first step. And what is the second step means, if the signs are different. Okay, so per suppose if you are taking two numbers like this, 24 and 12, so 12 having the minus number, no, so for that any negative number will have, okay, the addition of two signed binary numbers with negative number is there. Okay, with negative number is there in that, so that negative number will be represented in 2's complement. Okay, so if any negative number will have in that addition of two numbers, adding of two numbers, that negative number will be first converted into the 2's complement form. Okay, so after that whatever the result will get here, that result will be added to the added number. Okay, so whatever the result will get, that result will be added to the previous number. Okay, so whatever the larger number will have, after conversion of 2's complement of the minus number, that result will be added to the previous number. Okay, so then only we'll get the result. If any carry will be here, we'll do the adding method, right? Addition method will do. Okay, so after converting 2's complement, whatever the result will get, that result will be added to the first number. So after adding, we'll get any carry will be produced. If any carry is produced, adding two numbers, that carry will be neglected. That means we can remove that carry. Okay, discard that carry. Clear? This is the procedure to do the arithmetic addition. So I will take one example here. So the example may be like this. So I will take one number, that is plus 12 and plus 4. So these are given data we are having. So that is nothing but two numbers will have the same sign. So what is the step we need to follow? So the same step, if the two numbers will have the same sign, means the result will be having the same sign, right? So how to do the first addition process? Whatever the decimal number will have, that will be converted into the first binary. So I need to convert with, including with sign bits. So the plus is also converted into the binary. So how to convert plus sign? That is, in binary is nothing but we can represent it in 0. So for 4-digit code, that is 4 zeros. So 4 zeros, and 12 will be represented in binary is nothing but we need to write 8421 code. So how to represent it in binary for decimal means, how to convert, we knows already decimal to convert, we need to know, that is already we discussed in earlier classes that is nothing but how to convert binary decimal to binary. We have three classifications in decimal conversions: decimal to binary, and decimal to octal, and decimal to hexadecimal. So just check it notes. Okay, so 2 6 are 12, like this process we need to convert decimal to binary. So next 2 3 is a 0 and 0, and 2 3 is a 6 and 0, and 2 1 is a 2. We'll get the digit as 1100. Okay, this is the 12 of actual binary number. Okay, so like that we need to convert 4 also. So this is for 12 plus 12, sorry, and I need to convert plus 4 also. Plus is nothing but we need to represent the code as 4 zeros, and 4 for binary code as 0110. Okay, so this is the plus 4. So what is the next method? Addition. Addition is nothing but whatever the binary numbers we have, so that will be added here directly. Why? Because means here having the two numbers will be having same sign. That's why I can add directly. So 0 0 0 1100 and 0 0 0 0100. Okay, so 0 plus 0 0, 0 plus 0 0, 1 plus 1 0 and 1 carry, 1 plus 0 1, 1 plus 1 0 and 1 carry. So 0 plus 1 1. So 0, 0, 0. We'll get the final result as like this. 000, 100, 00. Okay. So now check it here. Plus 12 and plus 4. What is the result in decimal? That is nothing but plus 16, right? So 2 power 0. Just check it. Is it 16 or not? 2 power 0, 2 power 1, 2 power 2, 2 power 3 and 2 power 4. So these are 2 power 5 and 2 power 6 and 2 power 7. So leave it these terms. Why? Because means these are zeros, no? 0 into something 0. So where we were having 1, just count it. So 1 into 2 power 4 is nothing but 16 directly. Okay. So we'll get the same result. That's why it is having plus sign. And like that, this is the first step. If the numbers having same sign, this is the first step. And if the numbers having different signs, what is the process? Okay, if the numbers having different sign, so what is the process to follow? If the numbers having same sign means this is the process. What is the if the numbers having different sign, what is the procedure means? The same procedure we need to follow, but any different sign is nothing but any negative number will have. So what is the step we need to do? That number will be converted to the 2's complement. So the same numbers I can take it here, the example. So plus 12 and minus 4. Just check it, these two are having different signs. Okay, so what is the negative number will have? That will be converted into the 2's complement. Before that converting 2's complement, first we need to write binary numbers for these two. So plus 12, what is the binary number? Plus we need to always mention as 0 and 12 for binary number as 1100. And 4, what is the binary number? That is 0100. And what is the minus representation in binary means? That is represented in 1, right? So that's why I can take here all ones. Okay, so we need to add it these two numbers, but before going to do addition, so what is the process here? Whatever the negative number will have, that will be converted into the 2's complement first. Okay, this is plus 12 and this is minus 4. So here what is the negative number? That is 4. Now we need to convert this number into 2's complement. But except sign bit, what is the number will have? What is the decimal number will have? That will be converted into the 2's complement. So here except sign bit means except minus, we need to convert this 4 into 2's complement. Okay, so I can convert 4 as 2's complement, not sign bit ma. Okay, except sign bit, we need to convert that whatever the decimal number will have, that decimal number we need to convert. So I can take here decimal number as 4 except minus sign. Okay, except sign bit. Sign bit is nothing but here we can take it as minus. Okay, except minus, we need to convert whatever the binary number of 4, that will be converted to the 2's complement. So 0100, no, 4 of binary number. So this will be converted to the 2's complement. How to convert 2's complement? 1's complement plus 1. This is the formula, right? To convert 2's complement. So 1's complement, how to convert? 0 can replace with 1 and 1 can replace with zeros. Okay, so 0 with 1 and 1 as 0, 0 as 1, 0 as 1. So we'll get the result as 1011. And after that, converting 1's complement, will add 1 to that result, right? So 1 plus 1, 0 and we'll get 1 carry. 1 plus 1, 0 and we'll get 1 carry. 0 plus 1, 1 and here we'll get the 1100. So 2's complement of 4 is nothing but 1100. Now this number will be replaced in 0100 after that adding these two numbers. Okay, so I can write here. So what is the plus 12 number? 0000 1100. And next 1111. So in the place of 0100, what is the number of 2's complement of that 4? 11. So I can replace here 0100. So that is replaced with 100. Sorry, 1100. Is it right? 1100 and here we'll get the 0100, right? I can replace this 4 as this number. Okay, so now add, after that what is the next thing? After 2's complement, we'll adding that two numbers, right? So 0 plus 0, 0 and 0 plus 0, 0. 1 plus 1, 0 will get 1 carry. 1 plus 1, 0, already will get 1 carry here. So what is the result in between 1 plus 1? 0, right? 0 plus 1, 1, and this carry will be forward to here. 0 plus 1, 1, 1 plus 1, 0 and 1 carry. 0 plus 1, 1, 1 plus 1, 0, 1 carry. 0 plus 1, 1 plus 1, 0, 1 carry. 0 plus 1, 1, 1 plus 1, 0, 1 carry. So already I explained here, if any carry is produced after adding two numbers, what we will do? So whatever the carry will have, that will be neglect. Okay, so that means discard that carry. So I can remove that carry. So whatever the carry will have here, that will be neglected here. So we can remove that carry. So finally, what is the result here? 0000 1000. Okay, now check it. So plus 12 minus 4. What is the result generally in decimal? We'll get plus 8. 12 minus 4 is nothing but plus 8, no? Check it, is it plus 8 or not? So 4 zeros, no? This is represented as plus. 0 is always represented as plus, no? And here representing 2 power 0, 2 power 1, 2 power 2 and 2 power 3. 2 power 3 is nothing but 8. So 2 power 3 into 1 is nothing but 1 into 8, 8. So 0 into something, 0. So we'll get the result as plus 8. This is the procedure to do addition of any two numbers will having different signs. Okay. So per suppose, if the two numbers having same sign is nothing but here we'll take the two numbers having positive sign. I will take another thing. If two numbers having same sign but negative. Okay, already we know same sign of positive is nothing but directly we can add it. If two numbers will having the negative means, what is the procedure? Any negative number will have in that addition process, that number compulsory converted into the 2's complement form. So here one number will have the negative, no, that will be converted into the 2's complement. For suppose if your two number having the minus, no, that means negative numbers, no, the two numbers will be converted into the 2's complement. Okay, so I will take it here, minus 12 and minus 4. Okay, so generally what is the 12 number? That is nothing but 1100. That is binary, right? So now I will write it 1100 as binary of 12. But what is the minus? Will be minus is represented in binary, means that is represented as 1. Is it right? 1 is represented in binary, right? For minus, so 1100 and 1100 as 12. This is minus 12. And minus 4 how to represent? 0100. This is minus 4. Now we need to convert these two numbers into first 2's complement. Why it is converted into 2's complement means these two are actually negative numbers. Negative numbers, no, that's why we need to convert 2's complement of two numbers. Okay, so how to convert 2's complement means except sign bit. That means except minus sign. Except minus sign, we need to convert what is the decimal number we'll have here. Those are will be converted into the binary. That means 12 and 4. 1100 and 0100, those will be converted into 2's complement. So I need to convert 12 and 4 will be converted to 2's complement. 2's complement means first 12 we need to convert 2's complement. That is actually binary number as 1100 for 12. So this will be converted into the 2's complement means first 1's complement plus 1. Okay. So 1's complement means 0 can changes to 1, 1 can changes to 0. After that adding 1 with that number, right? So 1 plus 1, 0, 1 carry, 1 plus 1, 0, 1 carry, 1, 0. So this is the 12 of 2's complement. Okay, and like that also we can convert 4 also. So what is the 4 of binary number? 0100. So I need to convert this number into 2's complement. Okay, so 1's complement, 1's complement plus 1. So 1's complement means 1, 0, 1, 1. Plus we need to add it 1, no? So 1 plus 1, 0, 1 carry. 1 plus 1, 0, 1 carry. 1, 1. So 1100. Now whatever the numbers will get here, that numbers will be replaced with 1100 and 0100. After that we'll add the two numbers. Okay, so now I will add it 1111 for minus. And 12, what is the 12 of 2's complement number? that is 0, 1, 0, 0. And next by 4, that is 1, 1, 1 will be represented as minus, and 4 of 2's complement number as 1, 1, 0, 0. So 0, 0. Now add these two numbers, 1 plus 1, 0, 1 carry. 1 plus 0 plus 1, 1, and 1 plus 1, 0, 1 carry. 1 plus 1, 0, but will have 1 carry. 0 plus 1, 1. This carry will be present here. 1 plus 1, 0, 0 plus 1, 1, but 1 carry. 1 plus 1, 0, 0 plus 1, 1, and 1 carry. 1 plus 1, 0, 0 plus 1, 1, 1 carry. So whatever the carry will have here, that carry will be neglected. So finally the number becomes, what is the result becomes? 1, 1, 1, 1, 0, 0, 0. Okay. So this is the final procedure to finding if two numbers having same sign, that is negative. Okay. So like this process we need to find out the arithmetic addition. So now we'll do the arithmetic subtraction. Okay. So in that, the first one is arithmetic addition completed in signed magnitude form, and another method we'll have, that is arithmetic subtraction. Okay. Now we'll do that. So what is the next thing? Arithmetic subtraction. Okay. So subtraction of two signed binary numbers when negative numbers are in 2's complement form is very simple. Okay. So already we know, right? Negative numbers of 2's complement form, this is 1's complement plus 1. Right? This is very simple. And take the 2's complement of the subtrahend and add it to the minuend. Okay. So including sign, we need to convert first whatever the subtrahend number will be there. Okay. So arithmetic subtraction means, for suppose I can take one example here, some 24 minus 12. This is, we need to convert this number, we need to convert arithmetic subtraction. Okay. So in generally, in subtraction method, whatever the larger number will have here, that means whatever the number will have in that, so that is, we can call it as the, this number we can call it as the minuend, and this number we can call it as the subtrahend. Okay. So in subtraction, so what is the first number we'll have here, that we can call it as the minuend, or as we know that already. So what is the negative number we'll have, that we can call it as the subtrahend. So in that arithmetic subtraction, whatever the subtrahend number we'll have here, so including sign, okay, including sign bit, we need to convert that subtrahend into 2's complement form. This is the procedure. Okay. We need to convert whatever the negative number will have, that means whatever the subtrahend number will have, that will be first converted into the 2's complement. After that, converting 2's complement, whatever the result will get of this negative number, that will be added to this minuend number. Okay. So I can take here